Hello everyone, this is Mr. Mullo for the 7.2 lesson, Multiplying Polynomials. So there's three different ways to do this lesson. One I'll just talk about because I don't really like it and most kids get confused by it. One I'll do a problem or two on, and then my favorite method, and I think the easier method, will do more of the problems like that. So first let's go over some rules of what happens when we multiply things here. So if you'll see this symbol right here, the small square with the plus sign, that just means there's one. If there's two of them, that means there's two. If there's three of them, that means there's three. And then kind of the same thing, this small square with a negative sign in it, that means that's a negative one. And then you'll see we have these rectangles with plus signs in them. That means that's positive 1x. And then we have rectangles with a negative sign in them, and that equals a negative 1x. So going over rules, if I multiply 1 times 1, that gives me 1. If I multiply 1 times a negative 1, that gives me a negative 1. If I multiply negative 1 times a negative 1, that gives me a positive 1. So just going over the rules, if there's two positives, it equals a positive. If there's two negatives, it equals a positive. The only time we get a negative if it's an odd number of negatives like b there, where it's negative 1. Okay? Then here we have x times positive 1, which is just 1x or x. Here we have x times a negative 1, which is negative 1x or negative x. And then kind of they do the same thing and they just flip it. So now I have a negative x times a positive 1, which is still a negative 1x. And down here we have a negative x times a negative 1, which gives us two negatives, so a positive 1. Okay, so just saying kind of the same thing as a, b, and c, except now they threw the x in there. Okay, now kind of the newer part for today, what happens if we have the same thing with x's? Well, it's the same rule. So if I have a positive x and a positive x, that gives me two x's, so it's x squared. Okay, think about this if this was a number. Okay, we wouldn't just do two of them. Like if x was 3, 3 times 3 is the same as 3 squared. Some people are saying, Mr. Mullo, why isn't it the same as 2x? Well, because if that was x was 3, well, 2 times 3 is 6. And 3 times 3 is not 6. So it needs to be x squared, not 2x. Then same thing here, x times a negative x. That gives us negative x squared. Kind of the same thing if we imagine x is 3. So 3 times negative 3 is negative 9. Okay, doesn't kind of work for that one because it's negative 3. And then same thing, negative x and negative x. Give me a positive x squared. Again, imagine that it's 3 and 3, or negative 3 and negative 3. And that time it actually does work out that they're both 9, but not with I because one's negative and one's positive. Okay, so here's the first method that the book likes that I really don't like. They're kind of doing that same thing where they're just telling you to multiply those, and I don't really like it just because it uses all these symbols. But if you like it, it kind of tells you here what you would do. So like x and x give you that x squared. And then we have 2 of these negative x's and 3 of these positive x's. So like those 2 are going to cancel out with those 2. So I'm just left with like 1 positive x. And then I'm left with negative 1, 2, 3, 4, 5, 6. So negative 6. So that's how they would want you to do it, where you're kind of just putting everything like that. I don't really like it. I don't like those symbols. The other way that the book will want to teach you is called FOIL. Okay, and your parents have probably heard of this. This is how I was taught this. And then I found a better way when I was teaching, and I'll show you that way in a second. So FOIL stands for first, outer, inner, and last. So think of the numbers here. Most of your problems are going to have 2 things in the parentheses. So you're going to have like 1, 2, 3, and 4. So F stands for first. The 2 first numbers in each parentheses. So like you would multiply the 1 times the 3. Okay? O stands for outer. So what are the 2 outside numbers? So think of like the outside. That would be the 1 times the 4. I stands for inner. The 2 numbers on the inside. That would be like the 2 times the 3. And then L stands for last, the 2 numbers that are last in each parentheses, and that would be the 2 and the 4. So you're basically multiplying everything from each parentheses, and they just kind of came up with this to kind of help you keep it in order. Okay, so this is one way that they would do it. I have another way that I like better, but let's do a couple of these with foiling here so we can kind of keep it straight. Okay, so here, if I'm going to multiply the two first things, I'll do that in black. X and x is x squared. Now the outside, x and -1 is -1x. The inside, -2 and x is -2x. And then the last, -2 and -1 is +2. Okay, if you do foiling right, you should always be able to combine these middle two because they're both should have the same variable and the same exponent. So x squared plus 2, and then I can rewrite this middle one, -x minus 2x is -3x, and that's just going to be my final answer there. Okay, so that's it using the FOIL method. Let's go down to like number 5 and try that one. Okay, so same thing. So first, 3n and n make 3n squared. 3n and 1 just make a +3n. Then I do my inside. That gives me a -4n. And then I do the last. That gives me a -4. Again, if we did it correctly, we can combine our middle two there. So I get 3n squared minus 1n minus 4. And that's our answer, just multiplying those 4 ways. Okay, so that would be the FOIL method, aka the distributive property. Okay, if you like that problem, go ahead, keep doing it like that. I like this the best. So this is called a Punnett square. If you remember Punnett squares from science class, someone named like Gregor Mendel or Charles Darwin use this to find genetics of like, oh, if you have blue eyes and or if your mom has blue eyes and your dad has green eyes, what are the chances that you end up with blue eyes or green eyes or brown eyes because grandma has them? So they did these experiments and they used these squares. Okay, so I like these because it's really easy to kind of forget a step doing it the distributive method because maybe you don't do all 4. So I like this method the best because it's really hard to forget a step. So I'm going to put in those numbers. So x and a -3 go in that box. And then an x and a -2 go in that box. And again, you could switch it around if you want to do the other way around. Doesn't matter. And now for each boxes, you're going to kind of play like Battleship and see where they connect. So x and x connect in that box. And x is x squared. -3 and x connect in this box. And it's -3x. X and -2 connect in this box, so -2x. And then -2 and -3 connect in this box, and it's +6. And the same thing, if you did this correctly, you should always be able to combine these two boxes. So x squared, -2x plus -3x is -5x, and then +6. Okay, let's do another one. So I have y and a +1, y and a -6. So y and y meet at that box, that's y squared. Y and 1 meet in that box, that's y. Y and -6 meet in this box, that's -6y. And -6 and +1 meet in that box, and that's -6. And again, if we do it correctly, we should be able to combine these two. So I have y squared minus 5y minus 6. Okay, let's do one of these that had some letters in front here, or some numbers in front. So I have 2w minus 5, and then w minus 3. So w times 2w is 2w squared. W times -5 is -5w. -3 times 2w is -6w. And -3 times -5 is +15. Same thing, these two should be able to get combined, and they can. So I get 2w squared minus 11w plus 15. Okay, so again, I like this method a lot better. You're drawing a Punnett square. Usually when I draw it, I don't even do those top 2 boxes. I just kind of do this and then just put my stuff on top. I'll just do whatever. 2w, -5, and then 3, or w minus 3. I'll usually do that. I won't usually do these top boxes like they have here. Okay. And then here they want us to practice FOIL more. Again, whichever way you're doing it is perfectly fine. And then down here, another reason why I like the FOIL method is because now FOIL doesn't really work here. There's not a first and outer and inner and last because now there's three things here. So now FOIL isn't going to work. There's no cool rhyme that someone came up with to help you memorize this, but you could still use Punnett squares on these. You just have to make one bigger. So I can still do x over here, -2 over here, and do x squared, x, and -1. And if you leave a box blank, you know you messed up somewhere because there should be 6 things that you're multiplying. If it's a 2 by 2, there should be 4 things that you're multiplying. So especially some of you that like to do this in your head and like skip steps, I really like the Punnett square because you'll know right away if you skip the step because a box is empty. So x and x squared makes x to the third. X and x makes x squared. X and -1 makes -1x. And then same thing, -2 and x squared makes -2x squared. -2 and x makes -2x. And -2 and -1 make a +2. And then kind of the same thing as the other one, we should be able to combine our diagonals. So I have x to the third minus x, said x to the third, but I wrote x squared. X to the third minus x squared, and then -2x and -x is -3x, and then you have that +2 sitting there at the end. Okay, so again, everything's nice and neat and collected. We don't have to worry about missing steps here. All right, let's do number 23, and then we'll be done. Okay, so same thing. So I'm going to put 2n plus 1 here, and 3n squared, 2n, and -5. So 2n and 3n squared gives me 6n to the third. 2n and 2n gives me 4n squared. 2n and -5 give me -10n. And then 1 and 3n squared gives me 3n squared. 1 and 2n gives me 2n. And 1 and -5 gives me -5. Again, I can do my diagonals and combine those. So 6n to the third by itself. Diagonals 3n squared and 4n squared give me 7n squared. -10 and 2n gives me -8n. And then -5 by itself. So -5. So that would be my final answer. And this will be as hard as it gets. I think that there's nothing bigger than a 2 by 3 in there. But again, the wonderful thing about foiling, even if you get like a 3 by 3, then you can just make a tic-tac-toe board and put your whatever, x squared and x and 4 and x to the third and x and 2 on there. And you kind of just make your tic-tac-toe board and can multiply that way. Okay, so again, then you know if you missed a square or you got everything. I like this Punnett square method a lot. Plus then when you get to science class here in a couple years when you're learning the biology stuff, then you'll be like, hey, I remember that from math class.